25 years missed, 20% lost. Wow, a disappointing title, but I have the reason to talk about. So this is my short CV. I am a freelance inventor right now.
Yeah, keep closer.
Yes. As you know, in the past publications, past 5 years publications, the main research topics in embryo culture are the selection of the best embryo and the improvement of the embryo culture. According to the publications, selection is the subject of 90% of the papers. Improvement is the subject of 10% of the publications, or even less. I understand that there is a need for selection of the best embryos, but what if we make a little bit more focus and to improve the embryo culture system? Not 10%, but more. And then we can still make selection if it is needed at all. But why selection is preferred? Because it is a diagnostic procedure. It is easy to make. Why the improvement requires manipulation. The selection is supported by the authorities, by the people, because evidently they understand it is needed. Improvement is restricted because it is regarded as a kind of intervention with the embryo culture, and it is risky to realize. Okay. On the other hand, the selection is done almost entirely automated. There is one embryological procedure included when you make the pre-implantation diagnosis. It is the biopsy. It is a routine procedure. And everything outside, because it is made automatically by the time-lapse machine or externally in the genomics laboratories. On the other hand, the improvement requires work in the laboratory. At selection, you can sit in the office and just see the internet, then make a little work, then Instagram, then back again to the office. And it is a very convenient thing to make a paper. By in the laboratory, you have to work with the improvement manually, and attention is needed focus. And the selection papers are spectacular, very nice results, accepted by journals. Embryo improvement, embryo system improvement is usually a primitive procedure, and either the journal accepts and they say it is not really useful. On the other hand, the benefits of the selection are usually obvious, and the subject is advancing. Practically every month, every week, you have a new way how to select the best embryos. By the improvement is stagnating because it's not the subject of research. Only a few people do that. Does it help the selection? Everybody says it helps. It is very important. But there are some questions. Even the PGD with the PGEDA is questioned. I don't know if it is really needed as much as we do, as much as effort we invest. And the improvement, could it help? Potentially, yes. What I mean, if you have a bad system, every single embryo, even the best ones selected by the most sophisticated method, it is handicapped. So I think we should make a little bit more focus on the culture improvement approaches. At present, the optimization follows just the old ways. The solutions are optimized, the additives are optimized, the gas, the humidity is optimized. No, the humidity is disregarded. And the temperature is optimized. But in fact, in this field, no much advancement has happened in the 21st century. On the other hand, the physical environment, it is a questionable expression because it is not the solutions and additives are also physical environment, but I mean the three-dimensional environment of the embryos. It has almost exclusively improved for the time-lapse. And the purpose was to make the visibility better and the identification better. Various shapes were introduced, but they had absolutely not improved the embryo development. I think in the improvement, if you want it really successful, the key word is the microenvironment. And now let's talk about the well-of-the-well system, which is in fact a very small improvement. It can be described by this dish. Some microwells inside the dish. The system, which has now made a considerable advancement, has not been established because of the microenvironment. It was established for the handmade cloning, a very special way of somatic cell nuclear transfer. These embryos are zona-free, which produced by the handmade cloning, and they may assemble in the culture if they are cultured together into a mega embryo which cannot be used, or they can fall apart before the compaction, and we lose all the embryos. So we put the embryos into a small microbell, and we have success. We had millions of blastocysts in the well-of-the-well systems, and the development was much better than in the other systems. You may say because we just prevented the assembly or disassembly. No, two additional reasons. People usually disregard the fact that the zona pellucida in vitro is maybe harmful. And the solution exchange, the nutrient exchange is decreasing the embryo development. So zona-free embryos are a beneficial situation, but it is not at all exploited in human embryology. And the key word again is the microenvironment. But in the well of the well, there is a very special microenvironment. We did not care much when we made the cloning. But afterwards, a decade later, we started to have some evidences of the microenvironmental effect. And we have discovered that the size and the shape is very important. So what I mean, it is not unusual in reproductive biology that the size and shape is very important. But here, the large size is a problem. It should be smaller, in contrast to the other situations. And the wide diameter is also a disadvantage. So the smaller, the better. And the shape should be a kind of sugar mountain shape. You know, probably the mountain in Rio de Janeiro. Just imagine it upside down. And this is the optimal shape for the embryos. Mathematical calculations have clearly proved that the heavy molecules accumulate inside this well and the light molecules float out. I don't think it is very sophisticated thinking required for that, but it has been proved in a mathematical calculation as well. And analog methods, including the GO system, which is another subject, a small capillary, where you put the embryos inside 1 microliter capacity only, and you culture the embryos for 7 days in these bovine embryos, and you have 50% blastocyst rates, individual embryos, is also proving the positive effect of the microenvironment and the importance of the concentrated factors. And you know, in the culture, in the okay, I am talking to you. You know, it is a well-known group effect in traditional cultures, which are based on the similar mechanism. The embryos help each other. In the well-of-the-well system, the embryo helps to itself. And after these indirect evidences, we had eventually the ultimate proof. First, a light one, just from the author and the creator, which is not really interesting, but in bovine, we have found some improvement. Then again, a paper, but now from independent authors and from other authors. Now we have already 23 different references in 6 different species that the well of the well improves the embryo development. And eventually, we had a convincing human paper publication. Then 33% increase has been achieved just by putting the embryos into the well of the well instead of the flat surface. And another paper in porcine. And it was an 80% increase in some comparisons, 80% increase in blastocyst rate. And eventually, that's why I am here now, we had that information from the United States, apart from some other small experiments which all confirmed the positive effect of the level of the well. But this is an American clinic, part of the American Reproductive Society, and they provided us preliminary results, but very convincing. Just you have to see. On the screen, it's not visible. So 37% in flat surface, 55% blastocyst rate in the well of the well system at the age lower than 38 years. At the age higher than 33%, and 49%. Significance is not enough, but the numbers are interesting, and the patient's number is still low, but it is increasing right now. And in total, again, significant difference, 15% difference. 15% difference. Tell me sincerely, what has happened in the past 20 years in any embryo culture improvement, which improved the embryo development by 50%, 15%? Nothing. And we, you, everybody disregarded this possibility. I hope up till now. So I think it is a great thing which we all should focus on, and when available, we should use this system for embryo development. There are some additional benefits also of the well system. We all use very different embryo culture systems. We make the drops different size, different shape, we use different media, different tools, everything. The dish is different also, and we cannot compare each other's results. But if we use a global system, then every single factor can be tested individually. So this is one benefit. It is a good candidate for this system. On the other hand, the combination with fume dish, the humidity can be also maintained, and if you are interested, I can show you after the lecture how to do it by a dish. And if we combine the two dishes and we make a fume bow dish, we can hit two flies with one hit. This is the preliminary design of this combination. And then it is an excellent possibility also to make basic research about the optimal microenvironment, because you can collect very small amount of medium around the embryos and see what the embryos really need. So this is the Vita Vitro fume dish. The Vita Vitro valve of the well dish. You see, we made 3 compartments because people were afraid to use this dish. So this is the traditional time-lapse dish, flat surface, no real significant effect on the embryo development. And this is what I was talking about. Very small volume, sugar mountain shape, and on the bottom of the dish, you have the embryo and a very small, minuscule amount of medium. And this is some compromise between the two if you want to use it. But 16 bars, one dish is enough for most patients. So it is your choice what you use in the future, a swimming pool or a cradle for the embryos. I think you can imagine that feel much better, embryos that feel much better inside the well of the well than on the flat surface. So thank you very much.